In this video, we're going to be talking about the same points of concurrency that we talked about previously. So I have my arbitrary triangle here, and it's drawn to any random size. So I can move these around as I see fit to make this whatever type of triangle I want. So what I'm going to do first, I'm going to construct the medians. So I need to find the midpoints of these sides. And I'll use those midpoints to draw on our medians. So from vertex to midpoint of the opposite side. And the spot in which they cross, that is our centroid. So I will label that the centroid. And so it doesn't get too clustered here, I'm going to actually hide these medians in an effort to be able to see everything we want. But there's our centroid. Move things around and the centroid will still move with it because it knows where the medians are supposed to be. They're just kind of hidden from our view right now. Alright, next I'm going to create the perpendicular line through these, so our perpendicular bisector. So I select my point and my line, there's the perpendicular bisector, there's the perpendicular bisector, there's the perpendicular bisector. They also have the point of concurrency. And this is called, just select that, this is called our circumcenter. Now these, again, I'm going to go ahead and hide. Hide this and hide this. So you can see where our centroid and circumcenter are sitting. And once again, I can move things around. The circumcenter doesn't have to be inside the triangle, but that's where they would go as I move these things around. All right. Enough fun for now. Let's try another one. We want to find our angle bisector. And so I'll draw in the angle bisector. And I'll select point A, B, C. And there's our angle bisector for that. How about B, A, C? There's its angle bisector. And then B, C, A. All right. And so these three angle bisectors cross right there. Attempt to put the point on it. Let me move it so it's away from the other things. There we go. Point. There we are. And I will label this. This is our incenter. Okay. I'll hide these as I did the other ones. All right, and then the last one we did was our orthocenter. It was created by finding the altitudes for these. So again, I will make my perpendicular lines, and it needs to be perpendicular from there, going through A. So there's the altitude, measuring the height of this triangle from base BC up to A. And I'll do the same thing with all of these. So from the base to C, and then from the base to B. So to B. Not getting it stuck there. There we go. All right, so the point at which they cross, I will label that with its name. This is the orthocenter. That shouldn't be there. So I'll hide that, and I'll hide our lines again. So you can see the four points of concurrency sitting in our triangle. Okay, and so there they are, all four points of concurrency, and I can move my triangle around, and again, this thing will adjust based on that information. And what I want to show you is three of these four have a very unique relationship. And so if I stop there for a moment, what you're going to see is if I draw from the circumcenter to the centroid, this line, the line also goes through the orthocenter. And if I, again, just keep moving my triangle around, the orthocenter is always on the line that's created with the circumcenter and the centroid. So we know that the circumcenter, the centroid, and the orthocenter are going to be collinear with each other at any point. And what this is called, oh, didn't mean to zoom in, but here we are. What this is called is the Euler line. It's spelled E-U-L-E-R. It's named for a mathematician, Leonhard Euler. And even though it's spelled weird, that is, again, that's how we're going to pronounce it, Euler. And it just describes how these three unique points inside of a triangle are all collinear. For now, we are done.